Okay, so we were talking about just right there. Object-oriented concepts. Something left over from last class. Let's see, yeah, it's recording, cool. So, we were talking about the concept of object-oriented, right? And so why we're doing object-oriented? Our motivation of doing this object-oriented is because it's like facilitate your design, and because it's more close to our way of thinking, of exploring the world around us. Okay, accumulate the knowledge. So what are the three methods of abstraction I mentioned in the last class? Still remember?
Classification.
Yes, classification.
Generalization.
Aggregation, yes. Can anyone quickly tell me the difference? Classification.
Classification group things, objects in relation to their commonalities instead of their differences.
Yes. And then next, generalization.
Kind of generalizes. Okay, so generalization would be, as an example, I would say like dog, and, humans, cats, are like same type of animal, like the mammal. I think that's generalization.
That's
Instead of going into details about humans, right? Is that? Because
right.
you, me, him is like humans.
Yeah,
that's,
humans.
I think it's classification.
Yeah, that's classification.
You
Exactly.
have dog, cat, humans.
And then mammals, right? Animals.
Mammals.
Yeah. That's sort of like generalization. Yes. So classification is we group all of us together. We put some class there. Humans. Okay, maybe a student. Then on top of that, if we are trying to find something common between two category, okay, humans, dogs. Okay, we find the mammals, or just say a more general animal, or maybe someone do not want to be called animal, but maybe mammals. Okay. All right. Then what is aggregation?
Like a part of something. So.
Yeah. A keyword is has a relation, has a, like a kitchen has a top, a kitchen has a stove, okay, something like that. So it's part of something. Some object is part of another object, something like that. Okay, that's abstraction, classification. Right, so three keywords actually help us to understand and memorize. Classification, like, describes the instance of relation. Like, I am an instance of human. Then this is classification, and on top of that, generalization is a relationship.
I have a question with that.
Yes.
Isn't it kind of similar? Like if you say instance, you're like I'm an instance of human, and then you have is a relationship. So I am, like, you can say, he is a human. Right?
Yes, that is a is not like a, like before the is a you should put something like a category. It's more abstract.
Okay.
It's not instance. Like every instance is a, like, every one of you,
like a data.
you're instance of a human. You're instance of a human. You're instance of a student. But now that is like a human is Mammal? Yeah,
Okay.
something like that.
Makes sense.
So it's first one, classification is the relation between a category and an instance, and a solid instance. The second thing, generalization, is more abstract. It's a category. We combine the two category with we have another thing on top. Okay. And yeah, they are kind of similar, right? It's kind of similar.
Classification is classes, I think, right? Individual classes classification.
Yeah, classes or category. I call it category, but it's
And
actually
when
classes.
it's a parent, it's a generalization, is it?
Parent.
Yeah, parent class, like when you're inheriting from that class.
Oh yeah. That can explain this. So it's more abstract. Like class to class, they form a new maybe category, new class. Okay, and then that's how you getting to know this world. You kind of first you learn red, orange, yellow, and then we find something common. They are colors. Okay, and then colors. We find colors, and then for these colors, it's kind of abstract because it includes a whole bunch of different instances already. Then we know that that thing is called color. Okay, then we have something called voice or sound. Okay, we know this something called color exists. Something called sound exists. So on top of that, we can create maybe a color and sound. What are the things in common? Okay, maybe not sound.
Sun has a color. It's
Well, no. Maybe kind of movie. Okay, in the movie you see different colors, pictures, colors. You hear the sound, then you combine something. Yeah, that's sort of like they are like belong to no, that's is a part of movie. Yeah, that's kind of aggregation. Yeah, so but here yeah, I'm trying to find something that
You
can
have, like,
explain this.
Maybe different types of tables, and then different type of chairs, and then it's under furniture. Furniture
Oh,
is
yeah.
different class, and then
Yes. Okay, so we find something like color, different color furniture, and then on top of that, a table with color black, gray. Okay, a chair with a color yellow, and then on top of that, we know all of things is okay. They're or like furniture or something. Okay, in general, they are all object. Okay, on top of it, they are all object. So it's like two categories, two classes. Is they form something. Another new class.
What about like colors and then like primary colors and then it will be like red and then like primary color and then colors will be like all of them will be like a bigger class.
Oh, okay. I know that this. So we know that the colors, right? We found okay, they are all colors, and then we have all this electronic signals, those waves. So on top of the colors and the waves, they are all the waves. If you know physics, yeah, they're basically all the waves there. Yeah, maybe you form that idea in high school or in college, but they are all waves. And has its generalization. Okay, this generalization. Aggregation is, I think it's very easy to understand. It's part of. Okay, it's part of. That's how we learn the world, and that's how we learn the world. Then we can design more easily. Okay. In terms information hiding, have I explained this or not? Have I reached here last? Okay. Data abstraction. Abstract data type, that's what we're going to talk this week. Inheritance, polymorphism, yeah, I remember I talked about those. Okay, polymorphism is sort of hard to understand. If you all get the point of polymorphism, yes. Yeah, polymorphism is sort of like I'm holding something, like I can replace it with some other object. Okay, like I open a car with a key. Okay, so that thing called key, maybe it's a class, right? I can use it as a key of truck key, a key of sports car, sedan, something like that. I can replace that, but they all have some function, like like turn on the engine, like shut the door. Those are some basic functions. And when I'm using the class key, I don't have to learn what is exactly in the key, but I just need to know that every key has the same function: turn on the engine, shut the door, things like that. Then I can start using this class without knowing, like during the runtime, maybe I'm given a truck key, or I'm given another kind of key. So that's a good part of polymorphism. Okay, multiple and repeated inheritance. It means we have a class that is inherited from many classes. Okay, more than one classes. Sometimes in some language it's not allowed because it's create a lot of confusion. Like in Java, you can only inherit one class, inherit from one class, but you can inherit from, you can implement several different interfaces. Okay, remember what's interface? Interface is basically it's just a master name there with nothing implementation, with no implementation, and then you implement that if you like implement those interfaces. That's sort of like multiple inheritance, but basically it's just the Java multiple implication. It's just a concept. You don't reuse a lot of code, but if you think about pure multiple inheritance, a lot of issues there, like the same method from different class. So which one should be override? Or if you implement another one, which one should be implemented? Which one should be override? Okay, there's a lot of issues there. Or repeated inheritance. Have anyone heard of that? Repeated.
Child to child, it's like that.
Like you inherit from a class multiple times.
Is it like first class is there, the second one inherits the first, and the third class?
No, that's like the hierarchy.
Okay.
That's the hierarchy. But repeated inheritance is you can actually do. It's usually not happening, but you can inherit from a class multiple times. Yeah, that sounds weird, but sometimes you will need to use that. Sometimes it's a concept, but it's rarely used. But when they designed the OO thing, it is a thing there. Repeated inheritance, more than once to the same class. I was trying to think about. Let me. How about let's Google for.
It would be like you have class B and C, and they inherit from A, and then class D inherits from B and C, or something like that.
No. That's not the case. Let's see.
But how do they refer to the variables and all that?
See, there's a topic on this. I'm not using that at all, but it's not hard to learn something about it. Inheritance structure. Renaming. abstracts. Let's talk about a lot of details. There's multiple inheritance. We want to say repeated. Yeah. Yeah, okay, this is example. So it actually inherited the university person twice. Because teacher is a university person, student is a university person. Teaching assistant is actually a teacher and a student, but they are all university person. So that's how you do this repeated inheritance. It's multiple paths to the descendant. Let's go back. That's fine. Oh, that's it, right? Okay, so all these terms, you should be sort of familiar with most of it. If not, please check back this slides, or you can ask me. All right, let's come here. Okay, so we were talking about the object. So actually, one thing we need to think about is this abstract data type. Okay. So what are abstract data types? What is associated with the object? So it's actually, if you know those object-oriented programming, every data type, they are created, data structures, they are created as an object. So it matches everything. It matches everything an object should have. What object have is those data, right? So this data structures, all this, for example, array, they have this data elements there. Okay, so those objects, they have their data, and those arrays, they have their data. Okay, object have a state. The state is determined by the value of its data. Remember? Yeah. So the data structure is the same. The two data structure, like array, it has maybe two elements array, 0, 1, 1, 0. That's how different status states. Yeah. And also the object has the operations to this to their data, which can change the state of the object. So does this data structure. In data structure, we are trying to use this data structure, right? So like array, we are trying to insert the element to the array, or we read an element from it, or replace an element with something else. That's our operations, right? So, and everything is encapsulated in the object called array, right? So that's basically, data structures, they are basically object. A good example of object, okay? And how we design this data structure is actually, it will inspire us how we design some other problem, okay? How we solve other problem. Like a database problem, or a system, that management system, okay? Let's see some example of the abstract data type. So data types, okay, primary data types like integer, basically in some OO programming language, like integer is a class. It's called integer. Integer is a class, okay? You can create an integer from that class. You can do some more, like convert those things within that class. But most of the time, integer. It's just you're defining integer. Just use the keyword int, right? And string. Think about string. Just a string. So those are called some primary type. Primary type. So they're just defined as like integer is 8 byte. They occupy 8 bytes in your memory, and then it's sorry, 8 bits in your memory. 8 bytes. Bits or byte.
Can't be bits. Bits is too small.
Integer is 8 bits. Yes, 8 bits.
Integer?
Yeah.
It's 2 to the power 8. Yes.
Yeah, bits, right?
Yeah. I think it's 8 bit.
It's bits, 8 bits, sorry. 8 bytes is too large for integer. Yeah, 8 bytes is too large. Okay, so define 8 bits, and so that's it. You don't have like change things like to that thing. You can't reassign a value to an integer, but actually it's different than what we're doing with the array, something like that. Okay. But those are called primary type. They are not actually like an object. However, more complex data structure like array, list, those things are most of the time they are designed as an object. So abstract data type, basically 3 elements here. First, it contains a description of the elements that compose the data type. Like we describe an array. It's an array of integer. It's an array of student. It's an array of maybe building. Okay. And then it contains a description of the relations between individual components in the data type. For example, the array, the relation is defined by those index. Okay. So if we know like two elements with the index 0 and 1, we know they're next to each other in your memory, basically. And the 2 and 3, 2 and 4, we know there's one space in between. Okay. So that's a description of the relations between. And number 3, a description of the operations we wish to perform on the components of the data type. So like the operations, like the object operations, what you want to do with these elements. Okay, what you want to do with the elements. So then all these 3 things, they form an abstract data type. Why do we call it abstract data type? It's just a way we describe this data structure. It's not how we implement this data structure. Okay. So it is a data structure, and it's a data structure in a particular fashion. So here's the different level of specifying the data structure of the data. Okay. The lowest level, which we will never know, never understand, but it's hard to understand, is the translation of assembly code into machine code. 0, 1, 0, 1. Okay. At the end, everything's 0, 1 in the computer. On top of that is the assembly language. Have anyone learned anything about assembly? Okay. So assembly is a little bit higher level than this. You can read somehow, but it's not as readable as the higher level programming language. Think about C, C++, Java. Okay, that's at this level. We're implementing this data structure. Okay, but on the top, the most top one is the most abstract one. Is how we describe this data structure. Like we're not touching the implementation of that array. So from what I just described, you know what is an array. Array is just a whole bunch of space, right? The whole bunch of, that's actually implementation detail. So array is a set of this indexed elements, which you can use the index to retrieve the data, something like that. But down to the implementation level, it may be some space, memory space, next to each other. That could be static implementation of an array. Sometimes we have a dynamic array. You know what that is? Okay, static and dynamic. So static array is like when we initialize an array, we have fixed space in the memory. Okay, you cannot just increase that space. Okay, so more dynamic array, or if you think about the list, so you can create another space that will link to the last one, like a linked list. Okay, an array we can also implement it with a dynamic way as well. So if you think, recall how you initialize an array, like you define the type and you define the size, right? So that's static. Once you define the size, you cannot change it, right? But something called dynamic array is like, you create down there in implementation level. So it creates maybe 2 slots at a time, then you increase to 4. If you keep adding it increases to 8 somehow. Yeah, this way.
You know, your copy constructor, some like checks on you or something.
What's that?
You know, like a copy constructor and some checks to see if you're going to go over your size, and he's basically creating a new array which copies the data over each time.
Yeah. That's another implementation. There are a whole bunch of different implementation of the dynamic array, but that's something dynamic, and also something static. Okay, we done the dynamic or static. That's the implementation detail we need to decide. In decisions we need to decide. But up there in the abstract data type, we focus on more higher level. Like here, I don't know if you can see this word. Let me. Larger. Okay, that's cool. Good. Okay, 2 different parts. First is the definition. Okay, the ADT array. Here is an association between an